Now, for this particular questions, problems on quadratic iterations, it's always a good practice to start writing the first few iterations. Here, this is the procedure given. So if we repeat this procedure one more time, and this will be your second iterations. We can go on, but I'll start at second iteration. Because the question actually asks us to find 2 cycles or so in the end. So I suspect that I need up to 2 iterations. Now, to find A, let's do this. Well, we want to find invariance. So for invariant, we always set this the initial value be equivalent to the first iteration. And let's rearrange this and see what we get. Yeah, we have this. And then here, this equation 1, you see here they say this particular iterations procedure has exactly 1 invariant point. Now that implies that this equation 1 has just 1 solution, or rather a repeated solution. In other words, the discriminant of this of 1 is equivalent to 0, or well, you know, the b squared minus 4ac thing. So using that understanding, the a is 1, yeah, 1, -1, and c times c is equal to 0. We should be able to show that c is 1/4. And well, just to complete these writing the solution, I just sub this back into equation 1, and so I have z squared minus z, and this is plus 1/4 equals to 0. Now we don't like the constant to be in the form of fraction, so multiply across by 4, and you would get this thing here. Okay, so I call this equation 2, and what do we have here now? Okay, it will be useful later, I'm pretty sure. So in part B, now find algebraically all the 2 cycles. You see, when you're trying to resolve this and find all 2 cycles, there will be some byproduct, and the byproduct will be that at the same time you will find also the invariant point, because invariant points, they appear in each and every iterations. So it's essential therefore for us to know these invariant point, so that for us to segregate them between which points are actually invariants and which are not. And incidentally, we already have the mean to do so, because in this equation 2, we can actually, if you solve equation 2, you will be able to determine the invariant point, right? So now we would not need to resolve equation 2, but use it later. I'll show you how. Now for 2 cycles, all right. Here we will take the initial value be equivalent to this second iterations, plus c. Now of course, now we know what c is. C is actually plus 1/4 and square plus 1/4. Okay, now I'm not going to expand this and show you step by step, but I expect you to do that. Now if you expand this properly and correctly, of course, and multiply across by 16, I think you should get a nice equation which looks like this: 16z and plus 5. Okay, so here's, you need to do some work. I'm racing ahead without doing those algebraic expansion and manipulation. Alright, now as I mentioned just now, that we would definitely get some byproduct, and that byproduct will be invariant point. And so that means that, or rather it implies that this expression right here, part of the equation 2, would appear as a factor of this quadratic expression. Okay, because it's supposed to find invariant, and to find invariant is by solving this equation 2. So again, in other words, that this would definitely form a factor of this quadratic expression. So immediately we know that this is going to be 4 z minus 4 z squared plus 1 is a factor of this quadratic, and so the remaining factor would also be a quadratic. As here we have 4z squared. This is 16z power 4, and there's no way you can get 16z power 4 unless this itself is 4z squared 2, right? And here again, look at the constants. This is 5 here, and here we have 1, and there's no way you can get a constant 5 after the expansion unless this is itself a positive 5. Now we don't know what this is, so I'm going to put an a z here. Now what I'm going to do is trying to find the value of a, and so the idea is to completely factorize this, and you'll get my idea later. And so by comparing or equating let's say z term, I think that should be enough. So equating this here, the product of these two factors with this expression here, the z term on this prior to the factorization is minus 16. Okay, and here we have by inspection we should be able to see that this is minus 20z. Well, I just need the coefficient, and negative 4 and 5, and to get use 1 to get a z term, I have to multiply by a times a. So in other words, a is 4, right? Isn't it cool? So we have factorized this completely. So we have 4z squared minus 4z plus 1. Now remember, this factor will actually give us the invariant point, and we don't want the invariant point, so nor do we need to know the invariant point, at least for this particular problem. So all we need to do is just resolve this particular quadratic expression, as an equation. So we just need to focus on this. And here, if you by factorization, I think you probably need to use a formula. Yeah, I'm sure you need to do that. You're able to find that z be equivalent to negative half plus minus I, and so hence the two cycles, these two values are negative half plus minus I. So I hope that you try that and learn something from it. Thanks.